All right, CNT120, we're continuing on with Chapter 1. One of the first things they mention in the book here is network models, topology. That's basically how things are connected together, either physically or logically, if you will. Physically is literally showing how things are wired up, connected together, while logically has more to do with the software and logically how data is moving around, or logically how devices or people access things on the network. So if I look at a physical topology, it's actually showing this device connected to here, and you might even have details that show what port or IP address or things like that. Ethernet 1 port or Ethernet 2 port or Ethernet 3 port, that would be your physical topology, how things are actually wired together. Meanwhile, logical, we're not showing all that. We're showing more things like IP addressing and how things are accessing the network. It might even be showing how subnets and things are laid out, or VLANs or other things, and how we're organizing the network is arranged. That would be your logical topology. One of the next things they mention is what's called a network operating system. You kind of know what this is, but this term might be new, network operating system. It is really your server operating system, the server that's controlling things like what you have access to file-wise. What can I open file-wise? I can open the files in my folder, but I can't open the files in, Tom or Sally's folder. Those permissions. Server is also doing stuff like resolving names. When you type in hack.edu, there's a server actually responding to that and turning it into an IP address and searching out across the network. DHCP, there's a server handing you an IP address so you can actually connect to the network and get out through and open up web pages and so forth. That server operating system is required in your client-server network model. So they're mentioning this to kind of get you started of like, this piece is needed for a network model called client-server. Well, let's quick understand server operating system. Desktop operating systems we should recognize, and if I pull up the market stats, it'll be no surprise that the vast majority of desktop operating systems being used are Windows. That is not a surprise. Apple is pretty close second, and Linux is a far third, if you will. And these are things like these versions of Windows over the years. 3.0, Windows 95, XP, Windows 7, 8, 10, 11, etc. That operating system is for your desktop to do things like open files, work on files, be able to browse the internet, open email, that kind of stuff. That's what it's designed to do. If you have an Apple computer, these have been some of the Apple operating systems over the years. For a while, they were using big cat names. Then they moved on to like national park names. And they're still kind of continuing on that realm. Sierra, Big Sur, Monterey, Sonoma, Sequoia. These would be your Apple operating systems. Again, the same thing. It's the operating system interacting with the hardware, allowing you to open files, edit files, send emails, browse websites, listen to music, that sort of thing. That operating system. There is also a Linux operating system out there as well. This would be lesser known to people. It can be a desktop operating system, but it's usually used in the server side of things. But there is a number of different desktop operating systems out there. There's a ton of different Linux variations out there. That's what the distro watch here shows you. If you open that, that'll show you the kind of like the most downloaded versions of Linux for this time period. It actually keeps a running list of like the most downloaded operating system at present. There is a supported Linux operating system called Red Hat Enterprise Linux that ties together with Fedora. Fedora is the free product that allows them to develop the commercial product over here that they sell, that they can support for you. So this would be kind of one of the mainstream Linuxes that are out there, Red Hat and Fedora Linux. Well, as I move to the server side, those were all desktop. As I move to the server side, I have similar, but they are slightly different because they're designed to, as we said before, control access to files, handle IP addressing for a network, resolve names to IP addresses through DNS. They're doing a different function. So they're designed to be installed on a server and do those kinds of functions. Authenticate you logging in. Doug Brown, password. Yes, you're allowed on the network. Or no, I don't know who that user is. You're not allowed on the network. That's the kind of thing that your server operating system is doing. If I pull this market share up for servers, if you scroll way to the bottom, Windows has a big market share, but Linux sometimes even has a larger market share depending on the type of server you look at. So the two big players there are Windows and Linux. So if I look here, here's all different types of server operating systems. If I take a look at the Windows side, we have Windows NT up to Windows Server 2025. So as you go along, Windows Server, Server 2000, 2003, 2012, and so forth. Okay, these are different Windows Server versions over the years. Linux, the other big player, again, Linux can be an actual desktop, but it can also be a server. This actually sits on the fence and can be both. If I install Red Hat Enterprise Linux server, I can actually do those server functions that we mentioned before. Access, controlling access to the network, handing out IP addresses, resolving names to IP addresses, etc. And here's a bunch of Linux server versions. Now, these are ones that are actually, you can actually get support for. You can actually call and get tech support for. That's why I put these out here as an example. Apple for a while had their own server software as well to support their computers. And they had similar names to the OS at the time and just basically added in the server functions. And they ran that up until 2021, and then they discontinued. Because if you look, the market share of Apple server was very, very small. Basically serving anybody that had like a fully Apple environment. If you were in a ad or marketing or design agency, you might have had all Apple desktops, so you might have had an Apple server managing them. Not uncommon, but not as mainstream as Windows or Linux would be. In addition, there's one out there that probably most of you have not heard of that was Novell NetWare. These were actually, if you go back in time, this was the operating system, was really the first network operating system. It was out there before Windows and all the other ones. This had a big market share for a while, but then kind of faded out as Windows took over. Fun side note, the college, Hack the College, back in the early 2000s, was still using Novell NetWare for their main authentication server. So it's not something that is like totally in the dinosaur ages, but for a lot of places have kind of migrated away from. But Novell NetWare and the Novell Open Enterprise Server is still being used and made and supported. Again, much smaller market share. But these all have the function of doing what we said before, controlling people logging in, controlling what people have access to, controlling things like IP addressing and domain names and those sorts of things on your network. Now, a peer-to-peer model would be a network where all the computers are kind of equals, hence the name peer, and they literally control the sharing of information around. I can actually, put a folder here and share it and put a password on, allowing these people to have access to, and vice versa. So all the computers are sharing with each other. This is okay in a small environment, and actually in a small environment, I'll pick on our church. Once upon a time, we did this. We just had shared folders on like the secretary's computer, and the different people in the church, pastor, youth leader, children's leader, would put the files they want printed or put in the bulletin in the secretary's computer on their folder. They would open up, compile them all, and print them, kind of thing. And in that case, when you're dealing with 4 or 5 computers, it's relatively easy. And you don't need any kind of special server or server operating system to do this. So it is pretty simple to configure. It's less expensive to set up. I don't need that server or server operating system. I don't need licensing. However, it's not very scalable. If I had to do this for 20 computers, you start losing your mind of like, where's the shared folder? Who has access to it? Oh, their computer's not on. We can't get to their files, etc., etc. And it is not very secure because you're literally just putting a password on a folder. That's not very secure at all. So there is no central control. There's no central way to back things up. So it's really not practical for large installations. But in a small office environment, like I said, our church network, if you will, was like this for quite a while, which actually works for a small number of computers. And it's relatively easy setup to do so. As you get more computers, or have the need for more control or more security, you then move into the client-server network model. Hence us talking about the desktop operating systems and the server operating systems. So now let me go here. We now have a network where the server is the one that's acting as kind of like the traffic cop. Yes, you're allowed on the network. No, you're not. Yes, you can access this folder of files. No, you may not. So now we have a server doing all the control. And in many cases, this is a Windows network. So you have a Windows server maintaining the Windows computers through and what we call Windows domain. That's all the computers that server is maintaining and managing, that domain. And they're doing it through something called Active Directory usually. And Active Directory is literally, you can almost think of it as like organizing the users and the devices on your network. So I have here a admin panel that I have the users in here as well as the computers in here, and I can put things like names and passwords for users, and I can put on the computers what they're allowed to access. I can put in there what the users are allowed to access, and this is where all the control in a network happens. You literally put permissions on a user, passwords on the user, and then on the computers themselves. And this is what's controlling, as we show here, what you can and cannot do on the network. And the nice part about this is you now have that central control, but clients can now put their files on the server. So now the server can be backing up their data for them. And you don't have an issue of if this computer fails, they lost all their data. It's like, no, it's on the server. It's all right. We'll get you access to it. We replace the computer, put a new one in, map them back to that folder on the server, and bada bing, bada boom, they have access to their files again. So now I have the server in here that's maintaining the control of the network and what people can and cannot do. So the server is responsible for all these things now. The client data, authorization, controlling who has access to what files, restricting the network. If let's say somebody's a day shift worker and they're trying to log in the middle of the night, the server might be like, no, get out of here. This is not your shift. Why are you trying to log in now? And also restrict users. Okay, if somebody now is terminated or resigns or retires, we can restrict that they no longer have access to. Or they move to another job position, we restrict that they don't have access to this old pile of data, but they now have access to a new pile of data because their role has changed. Okay, and this is all being controlled by things like your Windows server, Ubuntu server, Red Hat server, or Apple OS X server kind of thing. So with this, and I think I have the pros and cons here. Here we are. Pros and cons. The users now have credentials to be able to log in. You can actually control and have multiple shared resources for them. This is able to handle a large company. It's scalable. And I do have that central admin. The central admin for controlling users and people having access to things. And in a situation like, I'll talk about hack. If I log into my computer in the Harrisburg campus in the lab room that I'm normally there, I can log in and have access to my files there. But I could also leave there, drive to Lancaster, teach a night class down there, log into a computer from there, and still have access to my same files because of this central admin. Okay, as long as I'm logging in with my correct username and password, it's like, oh, you're over here now? Okay, you can still have access to your folders. It's all right. The downside of this is it is not simple to configure and maintain. You need trained people to do this. You're not going to have, somebody off the street being able to set up and maintain and manage this network. It is more expensive. I need the server operating system, but I'm going to need to buy and install. It needs to be on a server somewhere. It could be a physical or virtual server. And there is licensing cost, usually in the form of the more people access, the more licenses you need for them to be able to access the server, almost like having a ticket. I need to buy more tickets for them to access the server. So it is more expensive to maintain. That is your client server model, which a lot of your businesses and companies will end up using when you're above. And they usually say something like a dozen computers, that sort of thing. So that's your peer-to-peer and your client server model.